So we're going to do some more examples. The first one that we have on the left-hand side is an example where we have the third root already written as a single fraction on the inside. But you'll notice that if we actually go ahead and try to simplify this, we'll get the third root. The fraction of the constants will simplify as 125. But the other parts, the q to the 6th, p to the 3rd, b to the 9th, there's nothing to simplify there, right? There's no variables in common. So we would have to leave it like that. So what we can do, though, is we can split it the other way. By putting the third root on the top, the third root on the bottom, and then simplify from there. So on the top, the third root of 125 is 5, because 5 times 5 is 25. Oh, sorry, 5 times 5 is 25 times 5 is 125. So this is going to be 5. Divide the q's exponent by 3 and you get q to the 2nd. Divide the exponent of the p by 3 and you get p to the 1. And then the bottom, 9 divided by 3 is b to the 3rd. So even though this thing right here simplified a little bit, but not very much, if you split it where the radical is on the top and the radical is on the bottom, you get actually something which is fairly nice down here. The other two problems require a little bit of work and a little bit of something that we did previously. So what I'm going to do is I'm going to rewrite this in a single cubic as m squared plus 7m plus 12 over m plus 3. Now the question really, if you look at it, is nothing gets simplified, right? Because there's addition on the top, addition on the bottom, and we cannot cancel division when there's addition on the top. So we need to first do something about that. So what can we do with an addition on the top, which is m squared plus 7m plus 12? What can we do to that to make it only multiplication? And hopefully you guys remember that factoring turns a polynomial into a multiplication problem. So what we're going to do is we're going to factor that. So the top ends up having an m, an m, and then the factors of this is going to be 4 and 3. Because 4 times 3 is 12, and then 4 plus 3 is 7. All divided by m plus 3. So now you can see that these will cancel because there's only multiplication on the top and the bottom. And you're left with the third root of m plus 4. That's it, you're done. Now, similarly on this other column on the right-hand side, you're going to need to factor. So first write it out as a cubed minus b cubed divided by a minus b, all inside of the third root. And you'll notice that this is a special case, right? The one that we've seen before. It's a difference in cubes. So we can factor that one as well as a minus b times a squared plus ab plus b squared, all divided by a minus b. So remember, your special cases are there so that you can factor these kinds of things very fast. So hopefully you remember these. These cancel out, and you're left with the third root of a squared plus ab plus b squared. Now, when you're actually looking at this part, right, you would have to try to figure out if this is factorable, right, so that you could see if you could cancel more with the third root. But what's really nice is the linear factors, which are the factors that look like a constant x plus a constant, the most that you can have of those is this one right here, which is 2. So the amount of linear factors that you can turn this into is 2. So you would never have a grouping of size 3. So this is actually the final answer. You can't do anything else with it.